Good morning and Jai Hind dear students. Today I am going to start the module 2. In the previous module we discussed about the physical properties of metals and non-metals. We also discussed some of the chemical properties of metals. Now in this module we are going to discuss the chemical properties, some of the more chemical properties of metals. Along with that we are going to discuss metal displacement reaction and how some metals they react with alkalis or bases. Now starting with this module, there are certain metals like zinc and aluminium. They react with strong bases on heating to form a soluble salt and hydrogen gases evolve. So you can see in this reaction, zinc metal is reacting with sodium hydroxide NaOH, which is a very strong base. It is soluble in water and so it is also called alkali. So zinc metal reacts with sodium hydroxide. On heating, it forms a solution which is called sodium zincate. Na2ZnO2 and hydrogen gases evolved. Similarly, coming to aluminium. Now aluminium also Al reacts with sodium hydroxide NaOH to form a compound or a solution called sodium aluminate, which is also called with the formula NaAlO2 and hydrogen gases evolved. Now next topic which we are going to start is metal displacement reaction. So what is metal displacement reaction? We can say a reaction in which a highly reactive metal or a more reactive metal displaces a less reactive metal from its solution is called metal displacement reaction. For example, if magnesium reacts with copper sulfate solution, or if magnesium is added in copper sulfate solution, magnesium being more reactive, it displaces copper from copper sulfate and forms magnesium sulfate MgSO4 plus copper. So here the displaced metal is copper and a colorless solution of magnesium sulfate is formed. Similarly, when zinc metal reacts with copper sulfate, what happens? Zinc metal being more reactive, it will again displace copper from copper sulfate solution and it will form a colorless solution of zinc sulfate ZnSO4, and you can see here copper has been removed. Then iron. When iron reacts with copper sulfate solution, iron is more reactive as compared to copper sulfate and therefore iron will form a solution or a compound which is called iron sulfate FeSO4. It is light green in color and the copper has been removed. You can see copper is the displaced metal here. So based on this reactivity, we observe that in this reaction some metals are reactive and they are able to replace the other metals from their solution. So we can arrange these metals from top to bottom in a sequential manner, whereby we can see the reactivity of the metal decreases as it moves from top to the bottom. So the diagram which you are seeing here is the reactivity series of the metal. So what is reactivity series of the metals? We can say reactivity series of metals is an arrangement of metals in vertical column in order of their decreasing reactivity. So see, the metals are arranged vertically. As they move from top to bottom, we will see that their reactivity decreases. Most reactive metals you can see are placed at the top and at the bottom are the least reactive metals. So this reactivity series you need to remember, and you have to remember because with this reactivity series you can know which metal is more reactive and which is least reactive. Potassium is more reactive than sodium, then calcium, then magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, gold, platinum. So we can say silver, gold, platinum are the least reactive metals. Those metals which are placed above hydrogen, you can see these metals are placed above hydrogen, so they can easily displace hydrogen from its solution. For example, if Na reacts with hydrochloric acid, then it will form sodium chloride. It will remove hydrogen because sodium is situated much above the hydrogen. So those metals which are situated above hydrogen or located above hydrogen, they have a tendency to remove the hydrogen from its solution. Less reactive metals such as silver, gold and platinum are found in free state. So they are also called inert metals and they are able to retain their shine for a long period of time because they don't react easily. Then coming to the next slide, chemical properties of non-metals. So when we talk about chemical properties of non-metals, we can say non-metals are electronegative elements. Why do we say that non-metals are electronegative elements? Because, for example, if we talk about chlorine, chlorine has an atomic number of 17. That means its number of protons are 17 and number of electrons are also 17. And if it accepts one electron to complete its octet, then what will happen? It will start behaving like a negative ion. So it will form chloride ion or Cl minus ion because it has accepted one electron. Similarly, oxygen, the atomic number of oxygen is 8. It has 8 electrons and 8 protons. But if it gains 2 more electrons, it will acquire the nearest noble gas configuration of neon, which is 10. So after gaining 2 electrons, oxygen will have now 10 electrons and number of protons will be only 8. So it has excess of negative charge and it starts behaving like an oxide ion, which is O2 minus ion. You can see here. So we can say non-metals are able to remove electrons from electropositive element and act as oxidizing agent. Now hydrogen is the only non-metal which can lose as well as gain electron. If hydrogen it gains electron, then it forms hydride ion, which is an anion. It is negatively charged ion. Similarly, if hydrogen loses one electron, it forms a hydrogen ion, which is H plus ion, which is positively charged, and so it acts as a cation. Then coming to reaction with oxygens, non-metals do react with oxygen to give certain oxides which are also called covalent oxides. Why they are called covalent oxides? Because of the formation of covalent bond, which you are going to study in higher classes. Now such oxides can be neutral or they can be acidic. So coming to some of the non-metals like nitrogen. Now nitrogen can react with oxygen under different conditions and it can form 5 different types of oxide. So some of the oxides with nitrogen can form, like nitrogen reacts with oxygen, it can form nitrous oxide. It again reacts with oxygen, it can form nitric oxide. It again reacts with oxygen, it can form dinitrogen oxide. It reacts with oxygen, it can form nitrogen dioxide, NO2, and nitrogen reacts with oxygen to form nitrogen pentoxide, N2O5. You need not remember the formula, you can remember the first 2 formulas, that nitrogen reacts with oxygen to form nitrous oxide N2O and nitrogen can react with oxygen to also form nitric oxide, which is N. So again, if dinitrogen oxides comes in contact with water, then what will happen? That is N2O5 dinitrogen pentoxide. If it comes in contact with water H2O, it will form nitric acid HNO3, which is a strong acid. So this is the reaction of non-metals with oxygen. Then carbon. When we talk about carbon, carbon is also a non-metal. It can react with oxygen to form 2 oxides, that is carbon monoxide and carbon dioxide. Carbon monoxide is a very poisonous gas. It has a tendency, if inhaled in large quantity, it can react with the hemoglobin present in our blood to form a compound carboxyhemoglobin, which when delivered to our cells and tissues will only supply carbon monoxide and can lead to death of cells and tissues. So coming to it, carbon, when it reacts with oxygen in limited supply of oxygen, carbon will react with oxygen to form carbon monoxide. If the supply of oxygen is less, then carbon forms carbon monoxide with oxygen. But if there is excess of oxygen, then carbon reacts with oxygen to form carbon dioxide. So this is the difference. Now this carbon dioxide, if it comes in contact with water, it will form carbonic acid, which is a weak acid, H2CO3. Similarly, phosphorus also reacts with oxygen to give 2 oxides, phosphorus trioxide and phosphorus pentoxide. Just you can remember that it forms phosphorus trioxide and phosphorus pentoxide. Then sulfur on burning in air form 2 oxides, that is sulfur dioxide and sulfur trioxide. SO2 is sulfur dioxide and SO3 is sulfur trioxide. So sulfur plus oxygen giving sulfur dioxide. Again, sulfur plus oxygen can also give sulfur trioxide. Now, this sulfur trioxide, that is SO3. Why I am using the term trioxide? Means there are 3 oxygen atoms. You can see here. So we are using the term trioxide. If there are 2 oxygen atoms, then we will use dioxide. So here we have SO3, that means sulfur trioxide. When it reacts with water, it forms sulfuric acid or H2SO4. Then coming to hydrogen. Hydrogen also reacts with oxygen to form an oxide H2, and H2O is also called water, and water is a neutral oxide. Reaction with halogens. When we talk about the reaction of non-metals with halogens, they also form certain covalent compounds which are also called covalent halides. For example, phosphorus reacts with chlorine. On heating, it forms phosphorus trichloride. Phosphorus can react with chlorine. On heating, it can form phosphorus pentachloride. Hydrogen, non-metal, reacts with chlorine to form hydrogen chloride. Similarly, sulfur also reacts with fluorine at high temperature to give sulfur hexafluoride. Why I am using the term hexafluoride? Because there are 6 atoms of fluorine, as you can see here, 6 atoms of fluorine. So it is forming SF6 and its name is sulfur hexafluoride. Coming to the next slide, reaction with hydrogen. So non-metals react with hydrogen, we can say, to form covalent hydrides. Thus in hydrides of non-metals, hydrogen is bonded to the non-metal atom by covalent bonds. The hydrides of non-metals do not conduct electricity, and the hydrides of non-metals may be acidic, basic, neutral, depending upon the nature of the non-metals. For example, when sulfur reacts with hydrogen, it gives hydrogen sulfide, H2S, which is weakly acidic in nature. So H2 plus sulfur will form hydrogen sulfide. Similarly, hydrogen reacts with nitrogen to give ammonia, NH3. Remember the formula of ammonia, NH3. Oxygen reacts with hydrogen to give water, which is H2O. As far as reaction with acids, generally non-metals do not displace hydrogen from dilute acids. We had seen that the metals were able to replace hydrogen from the dilute acids. But the non-metals, they cannot displace hydrogen from dilute acids. This is because non-metals are not able to give electrons. Metals generally lose electrons and they behave as electropositive elements. Whereas non-metals, they gain electrons and they behave as electronegative elements. So non-metals are not able to give electrons for the reduction of H plus ions. So non-metals, however, react with certain concentrated oxidizing acids to form corresponding oxyacids in extreme conditions. But generally non-metals do not displace hydrogen from dilute acids, and therefore they generally don't react with acids. So I will stop here. This module is over, and whatever doubt we have, we are going to discuss in the virtual class. Thank you very much.